Hello, everybody, no matter where you are. Good morning, good afternoon, good evening. Today's webinar is an overview and introduction to the new technologies and solutions that Arista recently introduced to support the next generation compute and storage. My name is Martin Hull, and I'm joined today by Hardev Singh. We'll be going through the product announcement, the solutions, the use cases, and their applicability to both enterprise customers of all shapes and sizes, and of course, hyperscale customers. When we look at the market trends for both hyperscale customers and a series of enterprise customers, we see two clear things. The first is that the hyperscale customers, as is well documented, are deploying large-scale AI and ML clusters, and their goals are to achieve the largest network radix within a defined latency budget. They're transitioning to the next generation of compute with dedicated 200 gig and even 400 gig connections. And they're striving to move towards an 800 gig interconnect capability. They're building out these dedicated AI and ML clusters as back-end networks for that AI compute. At the same time, they're expanding their intercloud bandwidth between sites, site to site, DCI, going from 100 to 400 and eventually to 800 gig and beyond. And because of the requirements of customers on that cloud capability, deployment of encryption technologies, but using both MACsec and IPsec is essential. And the other key driver for the hyperscalers is to reduce the infrastructure tax, the overhead, in ratio to the compute. That means if they want to build out that large-scale, high-diameter two-tier network using single chip architectures, flattening the network, lowering power and cost per gigabit of transfer of data. And one of the ways to do that is with the high efficiency that is delivered with next generation SerDes based on 100 gig or 112. You're looking at the raw bandwidth. Let's say the hyperscaler trend is well documented if you check out the public articles. We also recognize with the enterprise customers are doing similar things. They also want to migrate their compute, deploy the next generation of Ethernet, and they're starting to deploy on-prem AI networks or HPC clustered applications. But for the enterprise, backward compatibility and investment protection is just as important as getting to the next generation of high performance from a NIC. PCIe Gen 4 using native 50 gig and 100 gig capabilities, but with backward compatibility. As we're starting to see the next generation of compute get deployed, that next generation then drives the investment to get to the 400 gig from switch to switch, and a continued evolution, a transformation of the architecture to flatten topologies to cater for the east-west traffic. This is nothing new, but now we're seeing systems that need a support of from 25 gig to 400 gig speeds within the existing infrastructure. Very few customers at the enterprise get a greenfield site. So brownfield environment where upgrading and migrating and supporting the coexistence is just as important as the new technology. And where customers are deploying on-prem HPC or AI type applications, we're seeing the transition to 100 gig for all flash array storage, NVMe over fabrics, and cloud native containerized applications. And those themselves are driving the use of dedicated cluster technologies for back-end compute and front-end access to the infrastructure. So as we look at what it is that Arista delivers for these architectures, bear in mind we haven't changed fundamentally what we're doing. We have a single modern operating system, EOS. That one single EOS supports multiple, diverse, flexible silicon architectures. And those silicon architectures are delivered across multiple generations of that underlying silicon. So if you look at the Tomahawk class device, everything from a Tomahawk 1 to a Tomahawk 2 to a 3 to a 4. The Trident class devices, Trident 2, Trident 3, Trident 4, and then other similar chipsets, each delivering the best capabilities for the use case that they're positioned at. Bringing that one single EOS on top of those architectures gives you, the customer, consistent and open networking applications for automation, programmability, cloud networking, and telemetry and visibility. So one single EOS binary delivers a rich set of capabilities that is broadly delivered across multiple different architectures. So thinking more about the server and NIC speed migration, what we've seen is that for the cloud, you can look back a few years and see that, yes, 25 gig was a primary technology, but in 2022 and 2023, it's a 50 gig, 100 gig, and higher speeds. So for the cloud, the compute side of it, the server, the NIC, is all about 100 gig and higher. The enterprise customer, the picture is a similar shape. We have these bars of declining technologies and increasing technologies. But the blue at the bottom here is actually 1 gig going to 10 gig in orange. And then we see 25, then we see 50, then we see 100. So the enterprise for this year, 2023, and for the next few years is going to have a mix and max architecture of 10 gig, 25 gig, 50 gig, and 100 gig. So we need to make sure that we can support both of those types of environments, the cloud, high speed, the enterprise, medium to high speed. As those transitions take place over the next few years, we're going to see demand for network switches, network infrastructure that meets the needs of compute, storage, and HPC as we go through the refresh and growth cycles. So what we're introducing as part of this product announcement, this product release, is a new generation of an expanded set of the 7050X4 and 7060X5 systems that are targeted to what we see in the industry for both hyperscalers and enterprise customers that directly lower both OpEx and CapEx. So taking a look at compute where we are today, the compute has got a deployed scenario of 1, 10, and 25 gig down with 100 gig uplinks. The standard default top of rack switch is a high density 48 port 25 gig with 100 gig uplinks. That's aligned to the current generation of compute. It's based on PCIe Gen 3. The transition to PCIe Gen 4 brings in a capability that you can have native compute 10, 25, 50, and 100, and then that naturally drives the 400 gig uplink within that compute environment. For a storage environment, we saw many years ago that storage transitioned to 40 gig and in turn 100 gig. So based on that same PCIe Gen 3, we have a 40, 100 gig world with 100 gig uplinks. And the emerging solution there is the 100 gig to 200 gig down to the storage, and again, a 400 gig uplink requirement. And for those emerging on-prem AI, HPC clustered applications, they're already at 50 gig and 100 gig using PCIe Gen 3 and increasingly PCIe Gen 4. We're seeing the deployment of 100 gig to HPC clusters, but the next transition is to that, the NIC moving to 100 gig, 200 gig down to the device, and a 200 gig and 400 gig uplink. So as we consider we need to support all of these emerging technologies, we also need to support all the existing deployed technologies. As I said before, we don't get a greenfield environment in a large enterprise. We need to be able to support the existing status quo and prepare ourselves for what we know is coming, whether it's coming in the next quarter, the next year, or the next 2 years. We know that we're going to see the introduction of next generation compute, storage, and HPC with this need for higher speed. So I'm going to hand over now to Hardev, who's going to walk us through the products that we've introduced as part of this cycle of our 7050X4 and 7060X5 release.
Thank you, Martin. I'm going to be covering the new systems we announced last month in detail, along with some of the use cases in the leaf and spine tiers. Building on the success of the 7050X3 family, the 7050X4 series of products are really optimized for enterprise and cloud customers. They provide the same consistency with existing architectures and are loaded with features. Back in November 21, we launched 400 gig systems in the 7050 X4 family that were based on the 12.8 terabit variant of the Trident 4. Today, I'm going to be talking about 5 new fixed systems based on the 8 terabit variant of Trident 4. The two systems on the left are 48 ports of 100 gig, and the 100 gig here is the next generation form factor of 100 gig. This is SFP-based 100 gig systems. We have both the SFP-DD and the DSFP, and I'm going to be talking about, what are the differences between both of them in the coming slides. On the right, we have two systems that are basically 200 gig and 400 gig. So on the top right, we have a 1RU system. This has 24 ports of 200 gig with 8 ports of 400 gig. And the bottom right is a 1RU system, which is 40 ports of 200 gig. In the middle, at the bottom, we have a 2RU system. This also has 48 ports, but it's the 100 gig we know today. This is based on QSFP28 with 8 ports of 400 gig uplinks. All the ports on this system support MACsec. So the two systems on the left are really optimized for enterprise customers who are looking to support their existing 10 and 25 gig server NICs along with the new 50 and 100 gig, wherein these systems give them backwards compatibility to support the current server infrastructure they have, as well as the next generation PAM4 based NICs. The two systems on the right, the 200 gig systems, are really optimized for next generation storage and HPC with AI ML kind of applications. And the bottom right, in the bottom, the system is really optimized for the spine tier, where this can act as a bridge between 100 gig going down to the leaf uplinks and then native 400 gig going to the spine. This slide basically compares the two different variants of the Trident 4. Notice that the pipeline between both the variants is identical. What that means is your L2, L3 scale, your MAC addresses, your ACLs, all the features are going to be identical. The only difference is the number of SerDes. So because you have fewer number of SerDes on the 8T, you have a lower bandwidth. And the other thing to keep in mind is the logical ports, which define how many breakouts you can have out of a system. So the 12.8T system has 144 logical ports compared to 72 logical ports on the 8T variant. In terms of buffer, the 12.8T system has 132 megabytes compared to 82 megabytes on the 8T. As Martin showed in one of the charts earlier, the 10 gig and 25 gig server NICs are going to continue to be the majority of the server NICs deployed in the next few years. What that means is the 7050 X3 series of portfolio perfectly address those use cases, but we also see that the 50 and 100 gig server NICs continue to increase in the enterprise space. So these new 7050 X4 series of products based on the 8T chipset that are highlighted in yellow would be the optimal top of rack for those high-speed NICs. The 7050 X4 series of products are optimized for the needs of large enterprise customers, service provider edge networks, AI ML environments, and cloud networks, and are loaded with enterprise features for edge to cloud deployments. Customers often ask me, with the 7050 X4, does that mean it's a replacement for 7050 X3? And the answer is no. 7050 X4 complements the 7050 X3 portfolio. Customers can now build an end-to-end data center network with the 7050 X series with speed starting from 10 gig all the way to 400 gig, while providing that consistent feature set and architecture. So we covered the 7050 X series of products. Now moving on to the 7060 X5 series. So we announced 3 new systems based on the Tomahawk 4 chipset. On the top left, we have the 64-port 400 gig system. This was launched back in November 21. The 3 new systems we launched last month, the 2 on the right are 32-port 800 gig systems in a 1RU form factor. Again, these are 800 gig and not 800 gig Ethernet. And that's because the 800 gig MAC is not defined yet. The way to look at it is these are really 800 gig plugs, which gives customers the flexibility to use them as either 2 by 400 gig, or you could even do a 8 by 100 gig breakout out of these systems. So it's really providing them with this high density 1RU form factor in the spine or the super spine layer, where they are now optimized on power and provide high radix. We offer both QSFP-DD and OSFP form factors. On the bottom left, we have a new 32-port 400 gig 1RU system. This is the 7060 DX532. This is also based on the Tomahawk 4, but it's based on a 12.8T variant of Tomahawk 4. So think of this as a baby brother of the switch on the top left. Again, the key difference is the 2 systems on the left are based on 50 gig PAM4 SerDes, and the 2 new 800 gig systems are based on the 100 gig SerDes variant of the Tomahawk 4. So just to go over the different variants and the capabilities of these chipsets. So the Tomahawk portfolio has 3 different chip variants. So on the one on the left is a 12.8T. This is 50 gig PAM4 based SerDes, and we're building the 32-port 400 gig 1RU system with this. In the middle, we have a 25.6T variant, also with the 50 gig PAM4 SerDes. With this, we announced in November 21, a 2RU 64-port 400 gig system, as well as the compact modular 7388X5. Today, what I spoke about, those 800 gig systems, those are based on this 100 gig SerDes variant of the Tomahawk 4. So the bandwidth's the same between the two 25.6T variants, just that one is a 50 gig SerDes based and the other one is a 100 gig SerDes based chipset. So with that chipset, we're building the two 32-port 800 gig systems. If you look at the entire 7060 X series of portfolio, these are all based on Tomahawk chipsets. So in 2015, we launched the first set of products with the Tomahawk chipset, the 3.2T or the 6.4T. These are very popular. We sell them in high volume today, the 32-port 100 gig or the 64-port 100 gig. In 2019, we launched the first set of 400 gig switches based on the Tomahawk 3, which is a 12.8T chipset. And then we have 2 1RU systems, a 32-port 400 gig, both in OSFP and QSFP-DD, as well as this 4RU system, the 7368. In 2021 and 22, we now have an extensive portfolio of 400 gig products based on the Tomahawk 4, which are basically the 7060 X5 series of products. So again, to just summarize them, we have a 32-port 400 gig 1RU. We have a 32-port 800 gig offered in both QSFP-DD and OSFP 800. A 2RU system, which is 64-port of 400 gig, and then the compact modular 7388 X5, which I'll cover in detail in the coming slides. So to look at this compact modular system in detail, the 7388 X5 uses the 50 gig PAM4 variant of the Tomahawk 4. So the total bandwidth is 25.6T. It has a fully modular design. So at the front, you see you have 8 IO slots, basically 8 mini line cards, and the customers can choose between 2 flavors. They can either have a 16-port 200 gig IO module or an 8-port 400 gig IO module. The 4-port 800 gig is offered in both MACsec as well as a non-MACsec variant. At the back, you have power supplies and fans that are fully modular, as well as a switch card, which can be field replaceable. This system is highly power efficient. The typical power of this system is under 1250 watts, and it has the same Tomahawk architecture, giving you rich instrumentation and traffic management, as well as low latency of up to 825 nanoseconds port to port. This system is really optimized for large hyperscale spine tier deployments, where you really take advantage of this modular design. In case there's a failure on the line card, you can just replace the IO module or a power supply or fan or switch card. Basically, you don't have to bring down the entire chassis to replace any of the failed parts. What the 7388X5 system offers is reduction in power as well as higher radix. So if you compare it to the previous generation, which is a 7368X4, we see the radix increases by 2x. So the 7368X4 can offer up to 128 ports of 100 gig in breakout mode. The 7388X5 doubles that. You can have up to 256 100 gig ports out of that system. In terms of power, half the power. So there's a 50% reduction in power compared to the 7368X4. To summarize all the new fixed systems that we launched, so on the left-hand side, I have the systems based on Tomahawk 4. The top left is a 64-port 400 gig. In the middle, we have the 32-port 400 based on the 12.80 variant. And the bottom left are these new 800 gig 1RU systems based on the 100 gig SerDes variant of Tomahawk 4. On the right, we have 5 products based on the Trident 4 chipset, the 8 terabit variant of Trident 4. We have the 2RU MaxSec variant. Then in the middle, we have the 2 systems that are 200 gig. And in the bottom right, we have the 1RU 100 gig system based on the next generation SFP form factor. So let's go through some of the use cases with these new systems in both the leaf and spine tiers. The way to kind of read this slide is, I have these 2 bars. So you have the general purpose compute, this blue bar, and what it's showing you is what's deployed today is really compute based on PCI Gen 3, which is 10 and 25 gig with a max speed of 100 gig. What's emerging is PCI Gen 4 based compute. This is when your server NICs go to 50 gig and 100 gig with a max speed of up to 200 gig. So the 7050 SDX4 and SPX4, this next generation systems based on 100 gig SFP form factor, gives customers that flexibility and backwards compatibility to not only connect the new 50 and 100 gig compute, as well as their existing 10 and 25 gig. And also offers them investment protection, wherein they have 8 400 gig uplinks, which can natively connect to 400 gig to the spine tiers. The red bar here is really showing where the storage is today and the HPC clusters. So storage is quickly moving from 40, 100 to 100 and 200. And then with AI, ML, and HPC clusters, most customers today are using 50 gig and 100 gig down to the compute with 100 gig uplinks. So these new 7050 CX4 systems gives customer that option to connect the existing 40 gig and 100 gig, as well as the new 100 and 200 gig based compute on storage and HPC. You could actually use the 32-port 800 gig as a leaf as well. So with the 8 by 100 breakout out of each port, you could have a high density HPC AI ML cluster that you could technically build with these 800 gig systems as well. Again, to kind of reiterate, the point about how the server NICs are moving to the next generation. So what we see today is the 1 10 gig NICs are widely deployed in the enterprise today. 25 gig is quickly taking over 1 gig and 10 gig. And within that 25 gig NRZ generation, you also have 50 and 100 gig NICs, which are basically based off 25, right? So the 50 gig is 2 by 25 and 100 gig is 4 by 25 gig. The 7050 X3 portfolio of products are perfectly suited for this generation of server NICs. What we're seeing is, companies like Broadcom and Intel and Mellanox, they're releasing these next generation of server NICs, which are based on 50 gig PAM4. So you either have a native 50 gig SFP based NICs, or what's really popular among customers are these QSFP 56 based 50 gig PAM4 NICs. So again, 100 gig and 200 gig, but the 100 gig here is 2 by 50, not 4 by 25, like in the previous generation. And then also you have some vendors releasing SFP-DD and DSFP based server NICs. So the point I'm trying to make is this next generation server NICs based on 50 gig PAM4, the new products that we've announced, which are 7050X4 and 7060X5, are built as top of rack and leaf switches for these next generation of server NICs. Bit of a history lesson. So if you remember, 10 gig as a form factor, it first started with ZenPack, and then went to X2, XFP, finally standardizing in the SFP form factor. And that's because the SFP form factor provided the highest density. You could get up to 48 ports, down from the top of rack switch. It offered the lowest cost, the lowest power. It is the widely deployed form factor. 25 gig adopted the same SFP form factor, so did 50 gig. 100 gig again started with a much larger form factor, CFP, then went to CFP2, and then is now standardized on QSFP28. So what we're announcing last month are switches based on this next generation of 100 gig form factor, which is SFP based. So we have two different MSAs, SFP-DD and DSFP, and these two systems leverage both the MSAs. Each of these SFP ports, SFP 100 gig ports, actually have quad speed support. So you can support either a 10 gig, 25 gig, 50 or 100 gig server NIC. This slide basically shows the difference between, what is the technical difference between an SFP DD and a DSFP. They're different MSAs. So, they're both SFP-like. They both use 2 by 50 electrical to achieve 100 gig. SFP DD is very similar to QSFP DD, wherein you have an extra row of electrical connectors. DSFP, on the other hand, just uses some of the low speed pins and repurposes them to enable 2 by 50. It's just a different, design. Both these form factors are backwards compatible to 10 gig and 25 gig. We at Arista, offer customers the choice. So we're building systems with both these MSAs. So we have a SFP-DD as well as a DSFP based switch. Let's look at one of these very common general purpose compute use case in the enterprise. So today, the most widely deployed top of rack switch is this 48 port 1025 with 8 ports of 100 gig. And this switch offers customers to support either 1 gig, 10 gig, or 25 gig server NICs. As their bandwidth needs increase and enterprise customers are building new application to serve their businesses, there is a need for them to use higher speed server NICs, which are 50 and 100. And now their existing switches cannot support the next generation speeds. So with the 7050 SX4 48D8, these new SFP-based systems give customers that flexibility. So it has backwards compatibility to 10 gig and 25 gig, as well as support the new 50 and 100 gig server NICs. So they have investment protection as well as, in a heterogeneous environment where they have a mix of, these low-end and next generation server NICs, they can support all of that in one form factor. With the 100 gig uplinks, if customers upgraded their spine to 400 gig, they had to deal with 4x100 breakouts, right, which can be expensive. So now with this new system, you have native 400 gig uplinks, so customers can have cost-effective 400 to 400 gig connectivity to the spine and super spine tiers. So we looked at a general purpose use case. Let's look at an HPC kind of a use case. So today, commonly used top of rack switch is a 32 port 100 gig. And customers are connecting that to a 50 gig or sometimes even a 100 gig server NIC. But like I said before, this 50 and 100 gig NICs are actually 25 based on 25 gig NRZ. And the uplinks are still 100. So even though your spine tier may be 400, you are again dealing with that 4x100 breakout. With the new 7050CX4, again, we offer customers that flexibility. They can now not only connect their existing 50 or even 40 gig, 40, 50, 100 gig server NICs, as well as the new 100 and even 200. So the QSFP56 200 gig port is completely flexible. You can either run it at native 200, you can break it out to 2x100, or even 4x10, 4x25, or 4x50 gig. So it gives customers that flexibility to connect, a broad spectrum of server NICs, and has 8 400 gig uplinks, native connectivity to the spine tiers. Here is a specific example. So if a customer is building an AI ML cluster with high density 100 gig server NICs, so I've picked an example here of a server NIC which is quite popular, is a 2x100 SFP56 based NIC. And you can either choose one from Broadcom, which is the P2100G series, or the Mellanox Connect X6, or the Intel E810. All of these are 100 gig NICs with QSFP56 form factor. What customers are also realizing is, as you go to these next gen NICs and next gen servers, they're limited by the amount of power they can provision in a rack. So what we're seeing is 25 to 30, in some cases 32 is kind of the max number of servers you can put in a rack. So this 24 port becomes a nice sweet spot for them, where they can either connect to 24 200 gig server NICs. In this case, you're connecting up to 48 of these 100 gig server NICs with this DAC cable, which does a 200 gig to 2x100 gig breakout, right? So you can now build high performance HPC, AI ML HPC cluster with this 24 port 200 gig with 8 ports of 400 gig switch. Again, to go over the different 200 gig optics that we've released, the 200 gig SR4 is very similar to the 100 gig SR4. It is based on multi-mode fiber, the same MPO12 connector, giving you a reach up to 150 meters. The 200 gig FR4 is, in some sense, identical to this 100 gig CWDM4. So this gives you a reach up to 2 kilometers and uses that same LC connectors with single mode fiber. So customers do not need to change the fiber infrastructure while upgrading from 100 gig to 200 gig. You could also do breakouts. So a 200 gig SR4, if operated in a breakout mode with the MPO12 to 4LC breakout cable using multi-mode fiber, you can break out to 4x50 gig SRs or 4x25 gig SRs. So we looked at different leaf use cases. Let me cover one spine use case. So on the left, you see this chart is a typical leaf spine network. The leaf switches are, your standard 10 and 25 gig down to the servers with 100 gig uplinks. And your spine switches are native 100 gig, either a 32 port or a 64 port 100 gig. And the super spine could be either 100 or 400. What customers are looking to do is to upgrade their spine to 400 gig while retaining their existing leaves. So the two systems on the right can help you bridge that gap. They offer native 100 gig down to the uplinks of the leaf and have native 400 gig up to the super spine. So the 7050 CX4, you can operate it as a 24 port 100 gig or 200 gig down to the leaves, or the 2RU system with MaxSec, which has 48 ports of 100 gig QSFP28, which can connect down to the uplinks of the leaf and has native 400 gig uplinks going to the spine. So again, offering customers more options for a more seamless and simple migration from 100 gig to 400 gig. With that, back to you, Martin.
Thanks, Ardev. So as you have talked about there, we've looked at the new technologies, the new products that are allowing us to address the customer's need for a migration plan. Migrating 10, 25 to 50 and 100. Personally, I'm very excited to see the first use of the SFP form factor at 100 gig. I've been working in this industry long enough to remember the GBIG for 1 gig that rapidly transitioned to the 1 gig SFP. 1 gig became 10 gig, became 25, 50, and now 100 gig for an SFP. And so that's applicable to customers of all sizes in the enterprise, from retail to manufacturing, from finance to high tech, media, public sector organizations. What we often get asked by customers is, but what's next? What's next? And the answer after 400 gig is clearly 800 gig. And as part of our new product refresh here, we are introducing our first 800 gig 7060X5 series systems. As you showed before, there's 2 of them. There's a 7060 DX5 with QSFP DD800 plugs. There's a 7060 PX5 with OSFP 800 plugs. Both of them are fixed form factor 1RU systems with 32 ports of 800 gig. Those 800 gigs ports allow you to use 800 gig optics. You can use high density, double density 400 gigs. You can use single density 400 gigs, 200s and 100s, and you have many, many breakout capabilities. Based on the latest generation of the Tomahawk silicon with 100 gig SerDes, it has the same feature sets as we have on all the other 7060X5 systems. Rich protocol support for VXLAN, EVPN, and there is a full range of 800 gig optics and cables available now. We've been talking to many optics and cable companies for more than a year to make sure that their ecosystem of 800 gig is ready for prime time. So with the introduction of the system, it's effectively 20% lower power per gigabit. That power improvement is achieved through a number of things. The leveraging of the higher speed SerDes, so you have fewer lanes to get to the same bandwidth. The double density optics themselves introduce a power reduction, and then running it in a 1RU form factor rather than a 2RU form factor. These things together give us that power efficiency. Twice the density, 25.6T in 1U compared to 25.6T in 2U. And this first generation 800 gig system gives customers that migration capability where you can run high density 400 gig or high density 100 gig, and they will do it without forcing a change to the fiber plant that the systems are over. So if we look at how we're actually transitioning to 800 gig, well, the question is, what's after 400 gig for optics? And the answer is very simply, it's an 800 gig optic that looks the same as the 400 gig optics you're having installed today. There's no new form factor for 800 gig. We have both the OSFP and the QSFP DD form factor supporting 800 gig of bandwidth. If you look closely at the front of these optics, there's twice the number of connectors that you'd expect. They are 2x optics, two 400 gig engines inside one cage, inside one mechanical assembly. So we have two sets of LC connectors, or we have two sets of MPO connectors. So by going to 800 gig, we've really got double density 400 gig. Again, people say to us, so does that mean I can get 800 gig of Ethernet through this system? And the way we try to explain that is that in order to support 800 gig Ethernet, you need a few fundamentals. You need the 100 gig SerDes. So instead of running 8 by 50 equals 400 gig, you run 8 by 100 gig and you get an 800 gig interface. So we have 100 gig SerDes technology on the latest generation of the Tomahawk chip. We're running the 112 gig SerDes. That gives us an 100 gig technology that's available. It's on the Tomahawk 4. It's in the 7060 DX5 systems. So we've got the SerDes ticked off. Transceivers, as I just showed you, we have both an OSFP and a QSFP form factor, optics and cables available. So the final piece of the puzzle is the 800 gig MAC layer. The MAC, the PMAs, all the building blocks that actually build up the link layer. That requires next generation silicon. The Tomahawk 4 chipsets inside the 7060 DX5 don't have a native 800 gig MAC. 802.3CK that came out or was released in September 2022 allows the use of the 100 gig SerDes for 400 gig interfaces. 400 gig based on 100 times 4, a 200 gig interface based on 100 gig times 2, and a native 100 gig .1 based on a single 112 gig SerDes. So we've got a 802.3 standard, the 802.3 DF, which is the 800 gig Ethernet standard, is on a track to be standards based around about 2025. Don't want to give hard dates. These things never necessarily pan out exactly on a calendar. But again, the various standards bodies and consortiums have been talking for a while about how do we get to an 800 gig Ethernet spec. So there is a consortium, the Ethernet Technology Consortium specification for 800 gig based on 8 by 100 gig lanes and leveraging the 400 gig. So the 800 gig base ETC-R will be the first implementation of an 800 gig technology. So coming back to what do we do today on the 7060 DX5s, we have two types of optics available primarily. We have the FR4, the 800 gig -2 FR4 naming is to mean I've got double density 400 gig FR4 in here, two independent 400 gig FR4s. So on the picture on the left-hand side, you can see an 800 gig FR4 optic connecting to two independent 400 gig FR4s. So the 800 gig has got two pairs of connectors on it. A transmit and receive for one channel of 400 gig and a transmit and receive for the other channel of 400 gig. So that's how we get 800 gigs of bandwidth out of an individual 800 gig optic. You can plug an 800 gig 2FR4 back to back to another 2FR4 and you get 2 by 400 gig, or you can go to different independent switches. On the right-hand side, we have the parallel fiber solution, 800 gig -2X DR4. That in turn is able to connect to independent 400 gig XDR4s. Those XDR4s are MPO connectors. So the MPO connector of the DR4 400 gig connects back to an identical MPO connector on the 800 gig 2X DR4s. There's two MPOs on that optic. So the existing fiber that is deployed today, duplex or parallel, LCs or MPOs, coexists, completely just works with this new generation of 800 gig optics and plugs. So then let's think about how we do with breakout. So we've got the The picture here of those two examples I just gave of the two FR4s and the two XDR4s connecting to existing 400 gig optics. You've got an existing 400 gig infrastructure. You deploy a new 7060 DX5. You don't have to replace any of the 400 gig optics. You don't have to replace any of the fiber. You just need some new 800 gig capable optics for the spine or whatever tier you're putting that into. And then if you want to do a breakout down to 100 gig, an 800 gig to XDR4 will break out to 8 independent 100 gig FR plugs. So it's an 8x breakout capability. So following up on the theme that HiDev struck in terms of how do I do migrations? This is not so much a migration as a new deployment of how do I take this 32-port 800 gig system and deploy it in a network infrastructure where I've got 400 gig systems, either as leaf or spine switches. So if we've got the leaf switches with 400 gig uplinks, then we have a spine switch that needs 32 to 64 ports of 400 gig. We have a super spine that's the high density 400 gig today. We transition to this new technology. We still have the 400 gig uplink capabilities, and the spine switch, instead of being a 64 port 400 gig, switches over to being a 32 port 800 gig, and the super spine is now 400 gig, 800 gig ready. So those 800 gig optics that are being deployed can be deployed in high density 400 gig, high density 100 gig, and will be able to be deployed in high density 800 gig in future. So kind of summarizing all of this together, we've talked about the enterprise requirements to support backward compatibility, to support the existing install base, to support the next generation that we envisage coming in the next year or two. Transition that to putting on-prem, taking their infrastructure out of cloud-centric, maybe going hybrid cloud or on-prem cloud. That need to have an AI cloud-like environment supporting next generation 200 gig and 400 gig infrastructure for dedicated high performance workloads. Leveraging the same leaf spine architectures for next generation storage and high performance compute, coexisting alongside next generation generalized compute, and having support for a transition in the spine itself from having 100 gig down to 400 gig up, a next generation high density system. This portfolio of systems that we have in the 7060X5, the 7050X4, including the systems we introduced over a year ago with the 12.8 and 25.6T form factors, and the widely available 7050X3 systems, give customers a complete portfolio of systems for both the current and emerging technology requirements, for volume and hyperscale customers. So in summary, these systems deliver power savings, depending on your comparison and your model. It's either a 20% to 40% power saving capability. But by right-sizing the silicon that's in the leaf switch, right-sizing the silicon and leveraging the next generation of SerDes technology in the spine, customers get a meaningful power per gigabit, power per terabit saving. Leveraging the next generation of compact form factors based on industry standard MSAs for SFPs and QSFP-based systems, QSFP 56, SFP DD, and DSFP, allow us to expand the choices that customers have for both the rich and diverse compute, storage, and HPC connectivity. Not every customer requirement is the same. HiDev and I find as we're talking to customers, the question comes up like, what's the best recommendation for my top of rack? And the answer largely comes back to, what are your requirements? Are you leveraging brownfield, greenfield, looking at the highest performance, the lowest power? What are your requirements? So this rich portfolio of systems gives us that breadth that we can address all customer requirements, giving them the most choice, flexibility. With the first generation of 800 gig systems here, we have a 2x improvement in density with 32 ports in one IU, It's optimized today for dedicated AI and ML applications with the back end dedicated AI networks. And leveraging the very widely installed base of Trident and Tomahawk based 7050 and 7060X systems, feature and architecture consistency, not forcing a complete transition, whether it's something as simple as the fiber, the rack density, the form factors of the optics, the backward compatibility, or feature consistency, VXLAN, EVPN, tunneling, encapsulation, routing protocols, and of course, the single EOS binary image. So the existing install network and the new next generation network coexist seamlessly in your network environment. So hopefully what we've covered today helped fill in some of the blanks in terms of what it is that Arista is doing with this next generation of top of rack fixed configuration leaf and spine systems, and how they can be leveraged in your particular use cases, whether you're going from an existing 10 gig and 25 gig network, you're going from an existing 100 gig or 400 gig network. See how these can help you deploy the next generation infrastructure for both cloud and on-prem architectures. So with that, I know there have been a number of questions that have come in as we've been speaking. We've been trying to address those while the other person was actually speaking. What we'll do now is we'll pause and we'll take a couple of questions, and hopefully there's enough questions coming in when we get to yours.
So Martin, we have a couple of questions.
Okay.
The first one is 800 gig going to be mainstream anytime soon?
I'd love to answer that one. Anytime soon, depends on how you measure your timeframes. 800 gig is going to become a mainstream technology, absolutely. But at this point in time, I would say that it's very much for specialized use cases, in the same way that 2 to 3 years ago, I think 400 gig was being looked at in the same way, right? 400 gig, if you go back, where are we, 2023 now? If you go back to 2020, 2019, the first introduction of 400 gig systems, there were many questions around, well, who's this for? What does this value bring? Here we are in 2023, we're introducing systems with 100 gig down with 400 gig up for both spine and leaf. I think over the next few years, you're going to see the industry at large introduce more and more 800 gig capable systems, provide upgrades to existing infrastructure. So 800 gig is going to become mainstream. And really the question is, how long is that going to take? And then after that, of course, the question becomes, what's next? What's next after 800 gig? We're not going to answer that one today, but yes, I do believe that 800 gig will become mainstream, but probably not anytime soon.
Thank you. Next question. What is the optimal top of rack switch for someone moving workloads from cloud to on-prem?
The answer is the 7050X4 or the 7060X5 series. There is no one single answer to that question. I think we've demonstrated that today, that the answer depends on what your requirements are. And the good thing is that when your requirements are, talk to our sales teams, talk to our account teams, and they will hopefully guide you through navigating our portfolio to find you the best answer for your sets of use cases.
Okay, one final question. What software release will these new products support, and will they have feature parity?
You want to answer that one?
Yes, I can. So we plan to release these systems orderable in Q1 later this quarter, and they will start to ship in volume in the second half of this calendar year. The software release would be the EOS release at that point. We do 6 releases in a year. So depending on which quarter these systems come out, they will have the latest EOS image supported. And in terms of feature parity, these are extension of our existing 7050X4 and 7060X5 products. So yes, they will have feature parity with their previously released platforms.
Okay, so we took a few questions there. As I say, I know we answered some whilst I answer them when you're presenting and vice versa. So with that, I think we're running out of time. And I hope all of you have enjoyed today's webinar and will join us on future webinars as well. Thank you very much.
Thank you.